Hello and welcome back to Mrs. Powers Teaches Trig. We're doing some trig. It's algebra 2, but let's do some trig. And today we're talking about radians. And so let's just dive into the definition of a radian and then see if we can't make some sense out of it. It can be a little odd. So the radian measure theta of the central angle is the ratio of the length s of the arc subtending that angle to the radius r of the circle. And so it's s over r. Now, often you'll hear it's dimensionless, right? When we're talking about radians, like we have angles measured in degrees, but radians are just the radians. And you can see why it's a ratio. S is an arc length. R is a length. What's a length divided by a length? It's just a number, right? Because the dimensions get canceled out. And so really quickly, let's see if I can't draw a little bit of a picture here and try to get you to understand here. Pretend like this is right in the center and I have an angle here. Let's say it's theta. Okay? Theta degrees. In our case, we'll go with degrees because I want to start with degrees. And that angle, given a certain radius, right? We have a certain radius here, r. Okay. Do better than that. Let's go with this, r. Okay. We got a radius r, theta degrees. We have this arc here in blue that we get, and there's an arc length there. And so really quickly, what's the arc length of such an arc here? What is it? And it's very intuitive to get the arc length for this, because if I swung around from this bottom piece here, okay? So if we swing around this guy, we swung it around already theta degrees. We've gone theta degrees, and if we go 360 degrees, then we know we've gone all the way around, and we won't have an arc. We'll have the entire circumference of the circle. Well, the entire circumference of the circle is 2 times pi times the radius. Okay, but obviously we don't have that. We have part of it. And so what part of the circle do we have? What part of the circumference? Well, we got theta degrees out of 360 possible degrees. That is the part we have of our circumference. And so this is the arc length. Okay? So now if we mess around with this, we can find S over R, and we can get a bit of a formula to go off of. And so I want to take a look at that. So here it is. And I stole this Kathleen H on GeoGebra. It's geogebra.org/m/a2tztkgh. This is a really neat applet that I found that she made. I gotta say, I'm a fan. So let's take a look at this. So if we were to solve for r, we divide both sides by r, and we get this. And we could simplify it down even more, okay? And we would get S over R equals pi over 180 times theta degrees. Yeah, that's it. Rather than, so in other words, we have pi over 360 times 2 pi. 2 and 360 cancel out. We get 180. Okay? And then we can do conversions with that, right? We can take, well, if we have pi degrees and I want to find how many radians, the radians is the S over R, I'd multiply both sides by 180 over pi times 180 over pi. And that would get me my radians. I take my degrees times 180 over pi, and vice versa. If I want to go from radians to degrees, I'd multiply by pi over 180. So the trick of it really is, play around with it, is that pi radians is equal to 180 degrees. And so that's a nice little quick trick we can use when we're trying to convert radians to degrees. So let's say, or degrees to radians. So I'll just do degrees to radians right now, right? So if I have, we'll do 180 degrees. 180 degrees. I plug it in here. Or if I solve this right now, if this was degrees, so theta degrees equals 180 over pi times my radians. If I want to now, okay, 180 degrees, what is that in radians, right? What would you do? Well, for us, what we have here is, well, my theta is 180. So I have 180 equals 180 over pi times s over r times both sides by pi over 180. So times pi over 180 times pi over 180. All right. So what happens? I divide by 180 and then times pi. And what do I get? Those cancel. I get pi is how many radians I have. My s over r is pi. I have pi radians. So 180 degrees is the same as pi radians. Great. We can go back and forth. Piece of cake. Okay, so I just want to give you that idea. So if we want to extend this out, some important ones we like, 30 degrees. Well, times pi over 180. Well, 30 over 180 is 1/6. So times pi, it's pi over 6. Radians. And we like just rad. Okay. And so on. 30 degrees comes up a lot. 60 degrees comes up a lot. That's going to be pi over 3 radians. And so on and so forth. And so you can see, imagine if pi was the same as 180, 180 over 3 is 60. And it's a nice little trick. It works out great. And there you go. Okay? Now that I talked about that thoroughly, I went overboard on that, let's take a look at some other ways to go about this that are more intuitive and less algebraic. Okay? Like I said here, we got this little demonstration that the GeoGebra user Kathleen H made that I love, or she copied from someone. I don't know. We'll assume she made it. And we got this little angle measure thing to move around. And so we got S over R. We have a radius for each one of these. So my R for my radius for the red one is 1. The radius for the blue one is 2. The radius for the other one is 3. And then we're getting corresponding arc lengths to the angles. Right now it's a 90-degree angle, so we have a 90-degree arc. And you can see in each one, 1.57, that's pi over 2. Okay, then pi over 2, so that's pi over 2 radians. 90 degrees is pi over 2 radians. And we can swing it out even more to 180. And you can see, of course, our circumference is getting bigger, but in relationship to the radius, it's the same. Let's see, this would be pi. So this is 5 times pi, 15.7 over 5. 4 pi over 4, 3 pi over 3, 2 pi over 2, 1 pi over 1, pi. And so we got pi radians. Pi radians, 180 degrees. And we can keep going until we go all the way around. Oh, and it says, well, 360, 2 pi is same as 0, right? You end up in the same spot as we did at 0. Let's see if I can get something like 60. There we go. My pi over 3 pops up. But all of these really reduce to pi over 3, which is about 1, right? 1 radian, that would be, because pi is almost 3. It's a little bit more than 3, so that would make sense. Let's see here. And then could we play with this so we could get the arc length to be 1? If the arc length is 1 and a radius is 1, that should be exactly 1 radian, because it is the arc length divided by the radius. So it's between 55 and 60. We get 1 radian. We get close. And so we kind of see that. I thought this was a really neat thing, kind of fun to look at and mess around with. Now, one more, too, and this is by a guy who makes tons of stuff. So I know he definitely made this. Tim something. He makes great stuff on GeoGebra, really useful applets and things for teaching, for learning. So if you're bored and you want to look at his stuff, it's great. So this is his definition here that he made. And we just saw this, right? A radian it ends up being that your radius, 1 radian, whatever you have for your radius, that's going to be your arc length. That's 1 radian. So check this out. We'll spin this guy around. Okay. And then slide this thing down. That's 1 radian right there. How many radians in the whole circle? Well, we can grab these, move these around here. Oops. That is not what I want to do. Come on now. So I grab this. There we go. You can put 1 there. 1, 2, 3. 3 radians. It's almost pi, right? A little bit more. 3.14. That would be pi. That would be 180 degrees, right? More than 3 radians is more than 180 degrees. And so this is kind of a neat thing to look at, too. So I just wanted to show you this. This is very, very cool. Really, really helpful for us developing some intuition with this. And of course, 6 is going to be a little bit smaller than the whole circle, because 2 pi would be 380 degrees, which is like 6.28. So we got like 0.28 there to do. So it's pretty neat. Pretty neat. And he's got one more here if we want to mess around with it. So it's very, very cool. So anyway, that's it. And so that is our definition of radians, and we did a couple conversions here. So let's go ahead and do one more, but this time let's do pi over 4. Last one. What if I had... What's going on? 1 second. Okay, what if I had pi over 4 radians, right? Well, you'd multiply that by 180 over pi, rather than when we were doing this conversion of pi over 180 to go the other way, it'd be 180 over pi. But really what happens, be 180 over 4, right? Because pi's cancel out. In other words, again, treat the pi like 180. It's going to work out fine. 180 divided by 4. I should remember that. What's wrong with me? All right, brain fart. It's over. I know it is. 1 pi over 4 is 45 degrees. So, yeah, and 180 divided by 4 is 45. So 1 pi over 4 is 45 degrees. There you go. And that's it. So if we're going back and forth between these guys, it's pretty easy. So what do we do if we start with radians? So radians, 2 degrees, right? What did we do? We multiply by 180 over pi. Let's do it like this. Multiply by 180 over pi, or do my trick, just replace the pi with 180. There you go. And if we're going the other way, if we're going from degrees to radians, then we are going to multiply by pi over 180. Or again, just replace the pi with 180, as we could see up here. 180 degrees ended up being, or I'm sorry, 30 degrees was pi over 6. Oh yeah, so I guess it's a little trickier. You can just think, well, 180 over what is 30? 180 over 6. So pi over 6. That's the short, quick, easy, quick way. But you can, again, just multiply by pi over 180, and you will get your radians. So there you go. That should do it. So thank you for watching. Until next time, enjoy doing math.